So I want to talk about a recursive function. And a recursive function is basically a function that calls itself. It's used quite extensively in the area of computer science and in programming in general. Typically in a recursive statement, there's going to be a condition called a base case that determines whether the function needs to stop or continue with the recursive step. So in this assignment on 6.1, we're going to look at this pre-written code right here, and we're going to modify it and turn it into a recursive function. So this is the template code, and we're going to work with it a little bit. So in this case, the first thing I want to do is I want to modify the number of arguments that the Newton function is going to accept. So it's going to be accepting estimate because we're going to pass it estimate to itself. And since Newton is called down here, we're going to go ahead and change it right here. Right now I'm going to go ahead and pass it 1. I realize that estimate is set as 1 here, so we're going to go ahead and comment that out since we're going to pass it 1 to begin with. And that will start the recursive function. It's going to come in as 1, and then it's going to modify itself right here on this line of code and change every time. And then it'll call itself again. Of course, on the return, to make this recursive, it needs to call itself. So the function Newton is going to call function Newton. And we need to pass it the 2 arguments that the function requires. We'll go ahead and do it like this. Let's take this. I normally don't leave spaces in here, so let's get rid of those. Okay, so here that's working, and now we need to set what's called a base case to determine if it should break the tolerance or not. And we kind of get that idea going on right in here in the if statement. And so let's go ahead and work with that a little bit. And what I'm going to do is I'm going to say if the difference is less than or equal to the tolerance, then instead of break, what I want to do is I'm going to exit the code by saying, or the function by saying, return estimate. And then we're going to say else. And then we're going to put this in scope. Okay. And let me take a quick peek at this. I think this is good. Okay, so that looks like it. We're going to, right here in the main, we're going to go ahead and pass it the x value, which we'll enter that when on input. And we're going to pass it 1 to begin with. And so x and 1 will come here. It'll run into this algorithm, the Newton algorithm for this situation. And it's going to, if it becomes less than or equal to the tolerance, which is set right here, then it will return the estimate. It'll be done. It'll exit the function at that point. If not, it's going to continue to evaluate itself right here, calling the Newton function, passing it the value and the new estimate, and it's going to just keep recursively looping through itself until it finally reaches this case right here, and then it's going to return the estimate. So let's go ahead and run this and see what happens. So we have our control. Let's enter 2, and that's correct. Those are the correct numbers. So the program's estimate and the Python's estimate, it's all correct. And we did it very simply by converting this into a recursive function. And all that entailed was basically calling itself right here. So we made an adjustment here, a modification here, and a modification here where we had to pass it a 1. That was it. So that was just a quick example on how to convert a function into a recursive function.